Let's begin. My name is Christian. Today we'll be going over the basics of SCADA, otherwise known as UltimateAccess, and IPCs. So I think that we should just cover IPCs first, and then we can come over to the SCADA software. So one second. So let me see if I can get it better. Okay, we got a good view of this. So let's say you have to decide if you're going to use an HMI or an IPC. First off, what is an IPC? It's an industrial version of your computer. That's all it is. Let's remove the whole acronym from the equation. If we just dissect it, the I stands for industrial. The PC is literally your computer at home that you have in front of you, but just an industrial version. So what does industrial entail? That means that it has certifications that we're looking for to be in an industrial automation environment, such as FCC, CE, UL, CUL, IP65, and so forth and so forth. How does it compare to an HMI? Well, as opposed to an HMI, it it provides more capabilities in terms of processing power, memory, more communication interfaces. It can be much larger. I mean, some companies offer like 21, 19-inch HMIs, but it just depends on what company you're community or you're dealing with, right? So, and then IPCs, they can run Linux, they can run Windows, they can run your third party proprietary software or your own software. It just depends on the use case. So it has a lot more computing power. It can run any OS that you're looking for versus like an HMI where it's typically just a runtime, right? So on an IPC, I could have Windows 7, I could have Windows 10, I could have Linux, I could have any of those. But on an HMI, it's typically just a runtime where it's a very remedial application that runs your project. Whereas a PC, it can do everything that you're wanting, like joining a Zoom call for instance, like being on this Zoom call with me, learning about IPCs and SCADA is something that an IPC could do. It's not something you're going to use it for, but that's not something you could necessarily do on an HMI, to kind of paint the picture. Um, So then we have different types of IPCs. We have what we call box PCs or server rack mounted PCs, where they don't have a screen at all. And you might be wondering, well, what is the point of this thing if it doesn't have a screen? Not always does the user want to interact with the screen. Sometimes they just use it as a congregate area for data. So if you don't know what a cloud is literally just someone else's computer. They're just hosting data for you on their computer. So that's what a cloud is. And essentially you have these server PCs or these box PCs that can act as your local cloud server. They can host all of the data from your application onto them. Now, the difference between your box PC and a cloud server is that they have much, much more scalability. They have much more memory. But if you're only dealing with one application, one industrial automation application, you could have one server rack mounted PC, and then that could be the congregate for all of your data. But you would always want some redundancy in your application, so maybe you should have a cloud server as a backup. You never know what might happen. um, an act of God, like a tornado. Um, Something else might happen. Someone spills coffee on it for some reason that could destroy the whole thing. So it just depends on your level of comfort. So over here on the left-hand side, this is the point of an IPC and also maybe SCADA software being combined with it. So if we look on the left-hand side, we see that there is an IPC in the middle of everything. So it looks maybe similar to an HMI, but let's recall that there are subtle differences that differentiate them. So one is the computing power, one is the operating system that it can run, and then it can also run third-party software that typically you can't run on an HMI. Or you can't run on a remedial version of a screen device, right? So an HMI. So there is SCADA software running on this IPC right now. I'll go over the main differences between SCADA and like an HMI software after I cover this little manual here. So for this IPC, I could host the software on a web server that can be viewed over your phone, over a tablet. I can also shoot data up to the database, like to a cloud or to a SQL database. I can host or I can display the data onto a TV. I can send the data to a printer. Typically, you can actually send data from, or you can print screens from an HMI to a printer. So that's not exclusive to IPCs. But hosting to a TV, HMIs don't typically have display ports. PCs do. So you can actually you can extend the display with an IPC so you can have multiple screens. One of the beautiful things about SCADA software is you can have up to like 20 screens. It's like, like in those movies or in those TV shows where they have like 20 congregate screens together looking like a mainframe, etc. That's something that you can accomplish with SCADA software. SCADA can handle up to, I forget the number, but it might be like 12 to 18 screens for our personal SCADA. And then like basically that way you can remove page navigation from the equation and you can just see every single aspect of your project all at once. Considering that you have enough screens to do that though. All right. So then we have this IPC talking to 3 rack PCs or box PCs that are either grabbing data from different aspects of your application and sending it to the IPC, or it's just a basic interface for interacting like with a keyboard, mouse, or USB. You could remove these IPCs, these rack PCs from the equation and gain the same effect. This is just giving you an example of like how you could attach an IPC to field devices. You don't necessarily need these rack PCs, but it's a sort of like a redundancy measure or just an example, if you shall. So we see that the IPC could communicate with a PLC, a flow meter, some other field IO, or it can, what is not listed here is an HMI. So the IPC could definitely communicate with an HMI, a smaller, more remedial version of an IPC. So the different screen sizes that we offer here at CIMON for IPCs would be 10-inch, 12-inch, 15, and 19-inch. So one of those offerings we do not necessarily have for our HMI. We don't have a 19-inch HMI, but we have the 19-inch IPC, which, if we recall, is a little bit, or it's very different from an HMI because it can run an OS, has more computing power, etc., etc. Now, we do offer the capacity to run our HMI software, the runtime on our IPCs. So if you want to use the 19-inch as an HMI, you definitely could. You could definitely remove the whole computing power. Like it's still there in the background, but the runtime is going to take over, and then you would have it just be your IPC essentially. That way you get the whole 19-inch effect. 1 second. All right. So I think I pretty much nailed everything about IPCs that I really wanted to talk about. So if you have any experience with customizing a PC or making your PC, that is something that CIMON offers as well when you're creating your IPC. You can add extra RAM, you can add extra memory, you can provide like a RAID backup, or you can also choose your OS. So whether you want Windows 10, 11, 7, XP, you choose your Windows OS, we will install it for you. And you can also have Linux. So you're not stuck with Windows 10 or whatever OS that we're going to give to you. Now, one other note that you need to make for differentiating between a normal PC and an IPC is also the aspect of being fanless. So IPCs are inherently fanless. That's because you don't want to have to replace the fan in a PC every 2 to 3 years. And if the fan goes bad, you're not going to know until, it starts overheating and then shuts down by itself. And that's not something we can really accept in industrial automation, right? We can't accept any type of downtime that's unprecedented. So if you go the PC route in an automation setup, just make sure you take into mind that IPCs are fanless. They don't require any extra measures of care other than their memory and RAM. Just making sure that nothing's being overburdened memory-wise and nothing's being overutilized prerequisite-wise. Okay, so I'm going to jump from IPCs into SCADA. So we're going to go into UltimateAccess. That is the name of the software. So this is what the ideal industrial automation setup looks like from a broad picture perspective. So at the bottom tier here in the field, we have I/O devices, so inputs and outputs that are sending their data, their metrics to a PLC or an HMI, right? So that's the next level is control. And this is all done locally, right? This is done at the local standpoint. So you don't have an HMI that's communicating with multiple plants, and you don't have a PLC that's controlling multiple plants. You have a PLC that's controlling devices that are local to itself. We're talking like within a 100-meter radius, and the same thing for the X panel or the HMI. The HMI is coupled with the PLC typically, and it's looking to control a local vicinity of devices, like 100 meters we're talking about. Now, that information that it's all gathering can congregate at a SCADA software or an IPC, which is sent more than 100 meters away, right? We're sending data to the SCADA software where it will control, I don't know, upward of 50 different stations. It just depends on your application. Personally, I have used SCADA software to control 32 different locations, and you just do this with one SCADA software. It like congregates all of that data, so it helps provide analytics that you just wouldn't get with an HMI. So an HMI, at the very essence, is a historian device. It can, create a data log or alarms and trending for you, but it doesn't really perform analytics. I mean, in the near future, as technology evolves, it will be able to do that. But currently, right now, SCADA software is your analytic tool. You bring all the data into the SCADA hub, and it will provide analytics. It will also generate an algorithm that might potentially improve the workflow or improve the efficiency of your industrial automation application. So that's something that is very valuable that SCADA can offer that your typical HMI runtime cannot. Also, SCADA software is going to be running on an IPC or otherwise a normal PC, right? So it has that robust computing power that an HMI typically doesn't have. And I mean, you can also run your proprietary software and sync it to the SCADA software. It can be running with a SQL database and so forth and so forth. So that is like a lot of the time I'll get the question like, what is the difference between SCADA software and HMI software? They typically look the same, but SCADA offers a wider range of features. So you have the whole analytics, you have the algorithm producing almost behaving like a pseudo AI, right? It has the robust computing power of your PC. It can interface with more objects than HMI has. It has a lot more communication interfaces. So like an IPC or a PC is going to have more serial ports. It's going to have more Ethernet ports. It's going to be more versatile, right? So that would be the purpose of SCADA software versus HMI, is just more impressive. Now, if we look at this picture here, we have the network that is communicating to the SCADA software from the field I/O, and it can be either viewed over a phone or a tablet view or other computers on a web view. And then we can send that data to the cloud. We can send it to a SQL database. We can generate reports that are printed out for the CEO or for some other higher up that needs to evaluate the data correctly. There are just a lot more functionalities that come with SCADA software than you do with your typical HMI runtime. All right, with further ado, let's actually get into the features. So with UltimateAccess, that is the name of our SCADA software. So we have two SCADA softwares out right now. We have UltimateAccess 3.9, and then we have UltimateAccess Web 1.0 that will surely be here soon, that offers an HTML5 web server based approach to your SCADA control. And I'll go over differentiating factors later on in the presentation, but right now I'm going to go over the fundamentals. So this will be, and just so everyone's aware, this presentation is being recorded. I will give out all the deliverables after the presentation, so that includes the presentation and the IPC catalog that I just went over. I'm not going to spend time in the software. I just want to talk about like what you can expect from the software. How do you even use the software? What are features that we have? I don't want to put you to sleep, and so meaning that this presentation will probably cease before the 1 hour mark. So we can have a Q&A session if we need one. So let's go over database, scripting, trending, data logging, alarms. So another term that, classifies all three of these together would be historian. So when we say a device or a software has historical features, historian features, we're referring to trending, data logging, and alarming, because it tracks it tracks the data and then stores it locally so you can view it later, hence the term historian. And then we have reporting. So reporting is a next level to historian. So it takes the historical data, computes number, or it crunches the numbers, computes analysis, right? And then it generates a glorified data sheet that you can print out so someone can look at it, or you can just store it historically for yourself as well. So it's like a top tier historian feature that's not typically offered in your HMI software. 1 second. So another thing I want to talk about is security. So this is security within the software. So you can prevent unauthorized access within the software. Maybe you want to give some access to field techs, but like the engineer or the CEO would have different access. So you can have a different tiered approach in access to the project. It's not just one glorified password that controls the whole project. You can have 100 different tiers, and I'll get to that in the presentation. So what is a database? That is how you make your tags. If you don't know what a tag is, it is a variable that can host data and interact with objects in your project. So like turning a button on and off, or changing an analog value in a sense, or reading an analog value from a sensor, changing an analog value in a servo, something of that nature. You're basically using it to interact with an IO device or something locally, as like a stepping size, for example, right here. So in this example, these are all virtual tags, but more often than not, you'll be using tags to control real elements. So like your field IO, like turning a pump on and off, or reading an analog value from an HMI or PLC. So within the software, you'll see this toolbar right here. And then the database looks like this little tag icon, right? A little, like a tag, like an army tag or something like that, like a military tag. When you go into the database, you can create variables or tags like this. So number 1, you're going to press the plus icon, and that's how you create a tag. Number 2, that's where you name it. Number 3, that's where you differentiate the type of tag. So whether you want a digital, so Boolean, whether you want analog, so that could be integer, double integer, or float, real, word, double word, whatever terminology you're using, we have the synonymous partner to that. And then also string data, so alphanumeric, including symbols. And then description, so that is a reminder to the engineer or yourself what you created this tag for. Number 5, we have general versus advanced. So advanced, that's where you're going to be either controlling like whether it's what are the min and max properties, whether it's data logging, whether it's alarming, and so forth and so forth. And then number 6 is where it's going to either be interacting with a physical IO or a virtual tag. And then number 7, that is where you're going to declare what IO device you're talking to. So if you created an Ethernet IP device that you want to talk to, you're going to choose it at this location number 7. If you're talking to a Modbus device, you're going to choose it at location number 7. And then you enter in the correct IO address in this field right here below it. Number 8, there are some other minor parameters you can check and uncheck. So whether you want to cache the value when you're turning off the SCADA software, whether you want an action to occur when a value changes, whether you want to assign it as an alarm tag, and so forth and so forth. So there are a lot of parameters to take into account when you're creating a tag. But at the very essence, the default tag should suit you just fine. So all you would do is you create the tag, you choose digital, analog, or string, choose real or virtual. Most likely you'll probably choose real. Create your IO device, select it, and then you're going to enter in the correct IO address. So let's say you're talking to a Micrologix, maybe it's a B3:5/0. So that would be a bit value from the Micrologix PLC, and you could control that bit or that status of that lamp from the status of that bit of the PLC from the SCADA software. That would be the purpose of that tag, right? And then in the advanced tab, you could dictate what the initial value is. You could dictate whether it's data logging, the min and max value if you're using like an analog tag. You can declare the data type there, so whether it's a float, integer, or whether it's a double word. So that's enough about the database. That's how you create a tag in its very essence. So something to take into account with our database is you could interact with an Excel spreadsheet or any type of spreadsheet with the database. So if you highlight all of the tags or highlight one tag, you can copy and paste it into a spreadsheet. And then you can expedite creation of your tags through the spreadsheet and then control, copy, and paste it back into the database. Now, I can display that real quick if we want. So I have the software open here right now. Let me see if I can get this going. Let's see. Let me see if I can get this working with Excel. All right, so I copy and pasted that into Excel like this. So now the tag is inside. So I'm going to copy it and I'm going to delete this tag. 1 second, I have to sneeze. All right, so I'm going to delete this tag right here. And then I copied the one from, I copied it from Excel right here, and I'm going to paste it, and then there you go. So that is the compatibility that you see going from Excel to the database. And you can do that in a wider range too. So if you want to make multiple tags, you can copy and paste all of them from the Excel spreadsheet to the database very easily. It also helps that Excel offers like auto incrementing. So you could take advantage of the Excel feature, right? Like, so if you created one tag that had an index on it, so I'll go back to the presentation to show this. So if you created a tag that was called input.tag0 and you auto incremented to tag 5 by like highlighting everything and dragging down to tag 5, you could copy and paste that or copy and paste that back into the database and it will generate all those tags for you. So we have compatibility. Our database has compatibility with spreadsheets. That is a really good feature to have. Now for scripting, we do offer a scripting aspect. I mean, this is the automation field. Why would we not have this, right? So the scripting syntax or language that we will be using in SCADA or our SCADA software is going to be Visual Basic, and it looks something of this nature. Now, I'm not going to go through this entire script for you. You're more than welcome to copy and paste this script when you get the presentation or the recording, right, into the SCADA software that is free to download from our software, by the way, or from our website, by the way. So that is UltimateAccess. You just need to sign up to the website, download it. It's complimentary. It has a 4-hour demo license that you can refresh when you close and reopen it. So at the top here, I'm storing some variables. So these are internal variables to the script, not to be confused with a tag. So how do I read a tag value from the SCADA database? You can use the instruction get tag val, and then in quotations, you're going to want to write the value or write the name of the tag. So I'm storing more variables, I'm using a while instruction. So if you don't know what a while instruction is, that is a looping instruction that will continuously run all of the logic within it as long as the condition is true. And then we have a for instruction. So it's looking at the variable index that we declared, or, well, we didn't declare the index yet. But for indexes 0 through 5, we will run this down here. Index is looking at like the number that comes after like tags like input.tag, step size, and so forth. So we have another variable that's being stored right here. So if the index is less than 3, then generate or perform all of these steps below it. If the step size is, there's a bunch of other conditions here. It's an if then instruction, nothing really fancy there. It just means that we support if then. And then you need an end instruction that finalizes the if. Set tag val is how you write to a tag rather than reading from a tag. So we have get tag val that reads from a tag or variable, and then set tag value that sets a variable or tag. And then if the index is 3, it conforms to a certain instruction or parameter function, right? And then index 4, another condition that will perform a certain function. And then if it's not 0 through 4, meaning it's index number 5, it will generate this function right here as well. It will utilize this one instead. And then after all is said and done, we have a sleep instruction that tells the script to turn off for 1 whole second before it rinses and repeats. Because as I said up here at the top, we have the while instruction that will continuously run all of the syntax within this, between the while and the W end, all of this will run inconsequently until the switch instruction or the switch parameter is false. So as long as the switch instruction is the value 1, all of this will run and it will sleep for 1 second in between each loop. So that is the very essence of this script. Like I said, I'm not going to go through the nitty-gritty details of every single thing that's going on. Just noting that we can store variables, we can write to tags, read from tags, do an indexing-based script, we can sleep, we can use while, for, if. We handle all the basic scripting nomenclature or instructions that you are typically used to with other scripting languages. So, of course, UltimateAccess has the capacity to display tags. I mean, you want to see analog values on your screen. You want to be able to read tank levels and so forth. So that is what we call a dynamic tag. If you go to the draw dropdown and you go all the way down to dynamic tag, do not click on text or you'll be emailing me at support@CIMONinc.com for questions on like, why doesn't text show my tag value? So if you overlook the whole text object and you go to dynamic tag, you'll select that, and that is where you're going to select your tag name, and that is how you display an analog value or a Boolean value on an object. That is how you're going to read your analog reading. So if you're using a voltmeter and you want to read that voltmeter's value, you're going to use a dynamic tag and host the IO device or the IO tag that is hosting that IO device, and you'll be able to read it like that. So in your database, when you create the dynamic tag, you're going to select the tag name from your database, which is what we just went over. That's how you create the tag. That's how you assign the IO address. And then the final touch is embedding that tag into the dynamic tag, which displays the value. So there's multiple aspects to displaying a tag. You can display the name, the description. Those are modifiers for the tag. You don't just necessarily have to display the value of the tag itself. Typically, that's what 99% of the time it's used for, but CIMON does provide modifiers if you want to use those. So, of course, we support switch lamps. That's the very essence of HMIs and SCADA software, right? You want to turn it off and on something. So if you go to the draw drop down and go down to switch lamp, you click on the page somewhere, you'll get this interface to show up. 1 second. You'll get this interface right here that says switch lamp to show up. You can create a bit switch, a word switch, page, common, or a command script, command switch. Anything of those nature you can create. Typically, you're going to be creating a bit switch, right? So you're going to click on that. It's going to give you the option to choose what happens when it's a 0 or a 1, or maybe you just want to create a momentary button or a toggle button. That's where you would do this. You would create the toggle or momentary button from this object right here, the switch lamp object. So I can kind of show you that real quick. Create new page. So go to draw, then you're going to go down to switch lamp right here, click on the screen, and you'll get something like this to show up. I'll call it button. Call it bit switch. We can either make a momentary or a toggle. You're going to want to press set lamp as well. I can go in here. Did I make a digital tag? I should have. Let's just choose this one. And then I'm going to be toggling this digital value, this Boolean value. You're going to press OK. And then in the switch common or the lamp feature, it will automatically set the lamp status for you. You can go in here, select the status. So if I want to, or select the different states, what images govern those states. So it might make more sense if I do it this way, actually. And then I'm going to press OK. So I have now created a button that will toggle the value for group _ 0.di.l000. So it'll change the value of that digital tag from 0 to 1 whenever I click it. And it looks like this. So something very cool about the CIMON software, our newer software, not this one, or well, not this one, will have SVGs. So we are able to embed vector-based graphics into our projects. So if you don't know what a vector-based graphic is, that is where an object is, the quality of the object is computed based on a mathematical formula. So typically when you embed an image into a project, it will retain its resolution. Therefore, when you decrease the size, the quality can be diminished. But with vector-based graphics, whenever you change the size of the object, the quality is not tampered with. So for an example, if we go to library real quick, let's look at this object right here. So notice when I change the size, the quality does not change. I can make it larger or smaller and it retains that crisp image-like quality. Let's look at something like this. So CIMON offers over like 3,000 library images that you can choose from that are industry standard. So you're more than welcome to check those out. I'm not going to go through every single one of them, but you can change the size and the quality will not be diminished. So also we support copy and paste. So like if I were to copy and paste the screen right now, I could paste that in and you'll notice that I just made an image of the software itself. Or I can do something like this and then paste that in. So it's very easy to embed objects or images from external sources into the software at the click of a button, honestly. All I did was use a screenshot and then copy and paste it into the software itself. So we're getting a little sidetracked. We did make switch lamps. We did show you how to display analog values. That's at the very essence what you're going to be using the screen for. You want to see values and control things. So the main view or your SCADA screen is not going to look like this. This is way too remedial. But typically when I go through this presentation, I try to construct this for the end user or give them more time. This presentation was typically designed for 2 hours, but it'll just be me talking about it rather. So we have two buttons at the top left. Those are switch lamps, right? So I create a button where I can toggle a value on and off, or I create a momentary button where when I click on it, it holds it down, and when I let go, it makes the Boolean tag false. Or you can have it vice versa, it doesn't matter. Basically, the value is only changed as long as you're interacting with the button. It's not like a toggle that retains the state after you let go. Then we have all these question marks down here. What are all these question marks? I know I didn't write all these in, right? But these are dynamic tags. So when you draw a dynamic tag into the screen, it will look like that. So if I go to draw, I click on, well, it's called tag value here, but it's, this is dynamic tag. And then I'll choose the same tag. When I press OK, you'll see question marks. So these question marks just means that it's hosting a tag, a dynamic tag, right? And when I initiate the runtime, it will fill in the value with a 0 or a 1 or something of that nature. You had a question, David or Shane? 1 second. Are you not able to talk? Yes, Shane, what's up? You're able to talk now. I unmuted you. Or was your hand being raised not a typo, but a misclick? Feel free to write in the chat if you have questions. I think that might have been a misclick. I'm just going to lower your hand for you. And then go ahead and interrupt me if you do have questions. I don't mind slowing down and asking or answering questions. Oh, it looks like we did get it. Yeah, it was a misclick. That's what I thought. No worries. No worries at all. All right. So we're displaying tag values. We're creating switch lamp objects. These two buttons at the top right didn't really go through them. That's what we call page navigation. So on an object, let's say I draw a rectangle. I can draw a rectangle. I can go to touch. I can go to open page, and then I can just choose a page, right? So basically, whenever I click on this rectangle, it's going to open up this page called 3D parts. So that is what page navigation is. Now, I recommend with SCADA software to use replace page, not open page and close page, because open and close page is much different than the HMI. When you open a new page in an HMI, it closes the previous page as long as it was not a pop-up or something of that nature. It'll close the previous page because that's how an HMI runtime behaves. But with SCADA software, you can have multiple screens open at the same time. So therefore, we allow for multiple pages to be open at the same time as well. So if your intention is to close a page while opening a new page, use replace page. So replace page, and then 3D parts, voila, that's all you have to do. So that would be the more effective way of closing this page and opening up the page 3D parts. Just use replace page. All right. So that's page navigation at its very essence. So that's the little page I created there. So when you're creating a project, make sure you choose a starting page, or nothing will show up when you when you initiate the runtime. So that is located right here, this little computer screen. It looks a little bit different here than what I showed you on the slide. That's because this is the newer software. And then, so the initial screen for the PC, you can choose any of these screens to be your starting page, and then you can have a mobile starting page as well. So what does that mean? That means that this is HTML5 based SCADA software. I can view my project from a mobile smartphone, a tablet, or another PC. So we inherently incorporate the mobile web server into the software itself. So it's good to go in one package. So just make sure you choose a starting page for your project. So trending, very basic remedial feature. It just displays values on a graph. We have the capacity to do this. You can go to draw, then you're going to go to trend, and then you're going to create an object that looks like this. It's a trend graph. You can remove or enable user controls where you want to pause the graph, go back in time historically. The trend graph's historical features are completely based off of your computer. If you do not have um, if you do not have a lot of memory on your computer, then it's not going to store a lot of data for you. But I mean, it's hard to believe you don't have more than at least 100 gigabytes. Um, so typically computers will have way more than 100 gigabytes, but I don't know what your situation is. But this trend is storing data in the kilobytes or the bytes rather. So it's not using up a lot of resources, but maybe over the course of like 3 to 4 years, it could eventually hit into that gigabyte, like, the double digit gigabyte territory. So it can store a lot of data for you. The SCADA project I was involved in is still storing data from 4 to 5 years ago, and it has the data that I stored there back in 2020. So very useful feature if you're trying to track things historically. Can we create? You cannot animate new, or we removed animation from the new SCADA software, unfortunately. So, but since we removed the animation, we allow you to use GIF objects. So you can bring in GIFs. You can't necessarily control how fast they run or when they run. They just run. So maybe you can make them visible or invisible. That would be one way. And then have a static image lay on top of them. But no, we cannot animate the SVGs or any object for that matter in the new SCADA software. We removed animation editor, I believe. Yeah, we removed animation editor from the SCADA software. That was a question that I just got, and that's why I'm answering that. All right, so for trending, it's pretty simplistic. This is what it looks like. Now the trending is going to look a lot more crisp in the new software. I'm going to demonstrate that later. This is like our old version trending. So this is from version 3.9 of UltimateAccess. I will be showcasing UltimateAccess Web 1.0 in a little bit here. So data logging, as the name implies, it logs data. So it's just like trending. It's a historian feature that tracks data over time. So based on your computer's metrics or capabilities, it can store for a long period of time. We're talking about years and years worth of data. Now, the beauty of SCADA, though, is it can crunch numbers. It can use the information that you're logging and provide analytics and generate a better algorithm for your industrial automation application. So maybe the workflow isn't optimized. So that's what SCADA can be used for. It can optimize your workflow. So as very essence, you can turn off and on data logging. You can do it at a regular interval of 1 second, 60 seconds, however many seconds you need to store the data. You can do daily files, weekly files, monthly. The number of files can be capped, so meaning it would be a FIFO method, right? So say that we reach the whole max number of files 10. The first file will be deleted and then the 10th file will be created. So that's what FIFO means, first in, first out. So if you were created first, you're the first one to be let go, and then we have a new file created. And then we back up even if you don't want to get rid of the FIFO method, right? You don't want to use that, you just increase the number. Like you can increase it to like 3,000 or some absurd number. I think the max number allows you to store up to like 52 years worth of data, something of that nature. Like the computer will break before you hit that number. So just choose the max number of files and make sure your computer can handle that much memory. Shouldn't be that much memory in the first place, honestly. You can back it up even if you do reach that max number of files by overwriting or creating a warning before you overwrite. But data logging, it records data historically for you. That's all. Just like a trend. You can look at it via text or a CSV, so a spreadsheet or a text file. You can either automate this too. You can create like a CSV daily that you can look at, or you can create like a congregate, right? Like you create like 30 or 28 to 31 CSVs to encompass a whole month. You put that into like a folder and you have a CSV for every single day. So when you are audited, you can show them every single CSV and they can look at all the data and make sure everything was going correctly and that you're not lying about the numbers, something of that nature. So it does cover it does cover you. So this is what a text file might look like when you're doing data logging. You can expect that this data will be much more neat when it's in a spreadsheet. So you'll have the cells here that kind of govern the orientation, right? But we do have timestamps. It goes by the second. You can store the value every second, so forth and so forth. Alarms, everyone should know what alarms are, right? So they're notifications based on a threshold that a tag passes. So whether it's too low or too high, we can send a notification to the user that, hey, you've passed a certain threshold. This alarm notification has enabled. We can send an email or a text this way. I mentioned this on Tuesday, I believe, with SMTP. So we do have SMTP in the SCADA software as well. So for those that were not here, you can utilize SMTP to send text messages because certain phone carriers, I think most of them do, but certain phone carriers that I know, like Verizon, they have a domain that you can put at the end of your phone number that treats it as an email, but then sends you a text notification. So let me see if I can get an example going here. So let's say that your phone number is 555-555, this number right here, and then this is like the typical phone number that you see in movies and TV shows, right? But anyway, so this phone number, I want to send an email to it. All I have to do, if it's under the Verizon carrier, is just put that phone number at vtext.com. I will send an email over SMTP to it, but it will show up as a text on your phone. So that is one way to break away from needing a third-party carrier or some type of SMS protocol on your SCADA software. You can just use SMTP if you have that offering, which we do on our SCADA software. So alarms can be used to send notifications to users or anyone else that something is going wrong with the industrial automation application. Otherwise, it can just be used to, kind of audit the system, see what is going on here and there. To assign a tag to be an alarm, whenever you create the tag, there's a checkbox here and it says assign as alarm tag. So that is how you do that. You check the box, you'll get a new tab that says alarm. Notice it's not there by default, but when you check this box, the alarm tab will show up, and then you can set the high, the high, the low, and the low, low. So what do all these different thresholds mean? High, low, low, high. What do all those mean? So high and low are generally safe thresholds that you can pass. It's kind of like a warning. And then high and low are like your extreme alerts. Like, hey, you've passed a pretty strenuous threshold. We need to like alert you and you need to act now. It's like it's an extreme notification that requires intervention. Whereas high and low are kind of just like warnings like, hey, you passed the threshold, maybe monitor it, but then it'll probably come back down and go back into like a more, a friendlier steady state. Or like you'll go back to equilibrium inside your project. But once you pass that high, the low, those are certain thresholds that you want to be notified immediately, and you need to take action to change the route of your application to make sure no one's hurt or making sure that nothing is passed. So an example, maybe let's look at a water tank, right? So a high and a low could be like 80% and 20%. Now those aren't very critical values, but like we could have the high and the low be like 10% and 90% respective, or the high be 90% and the 10 or low be 10% respectively, right? So once you pass the threshold of 90% in a water tank, that's very dangerous because water is one of the most destructible forces on Earth. And if you were ever to reach 100.1% of a tank volume, you're going to shatter the tank because water doesn't conform to a solid. Solid will conform to water. So you can't compress water. So once you've reached 100%, you're at capacity. And you go 0.1% more, you're going to start breaking that tank and it's going to start shattering, right? Because that's the whole point of volume. So you would want to be notified when you pass 90% because you need to intervene immediately. That means that the drain system is not working accordingly, or the pumps are working too hard. They're not turning off when you tell them to turn off, something of that nature. There needs to be an emergency contingency for when you reach certain thresholds. Likewise, on the low aspect, if you're below 10%, that might be a cause for concern. Maybe the pumps aren't working. Water is not being delivered to whatever locations need it. Not as big of a concern as high, because something could be destroyed, but low, water is just not getting to where it needs to get. All right, so that's how you create alarms. You can also have alarms for Boolean values. So if you have a digital tag, when you create an alarm, you'll have a different interface. You can just choose between off, on, off, of that nature, whether it's off always or whether it's on always. It just depends on your application. So you can have alarms for Boolean tags and analog tags. An alarm summary is just what the name implies. It's a location where it will store all of your alarm metrics, like whether it's on or off. It's to summarize what the statuses of your alarms are. So there's historical alarms, and then there's real-time alarms. So I don't want to spend too much time on this because we only have 10 minutes left. Gosh, I am good at yapping. So we have alarms here as well. I can create like a historical file on your computer by clicking on this tool button right here, or this icon right here, and then choosing the location of where I want to store that. So you're going to click on File, press Edit, and then you choose the location on your computer that will store the alarm file. Now, the important aspect of this is to track nefarious action, in my opinion. Otherwise, the GUI object will store everything for you. Nefarious action meaning maybe someone fell asleep at the wheel, an alarm happened, they woke up, they realized, oh, I shouldn't have fallen asleep, and now an alarm happened, I don't want to get in trouble. They can actually delete the alarm. So you can remove the delete button from the alarm summary, or you can track it historically and it will take into account deleted alarms. They will not be able to find this, I promise you. As long as you can store and tuck this away in a proper place, you will be able to track nefarious action within your project. So this is what a text file looks like, right? It'll tell you if an alarm was deleted, it'll tell you variations, it'll tell you off and on, so forth and so forth. This is what you can expect from an alarm historian file. So a feature that we haven't really talked about is reporting. Reporting is a glorified example of a historian file. So I'm going to skip all of this. What it can be used for is something of this nature. It can be interacted with a customizable spreadsheet that you can then print out and give to a CEO or give to the engineer, or you can analyze it in front of you. It just depends. Maybe you have a record keeper where you keep a bunch of sheets in like a binder. I mean, that's pretty archaic these days, but it just depends on how you operate your industrial automation application. So it can print out a sheet if you need to, or you can just print it out as a file that you can store it within locally. It's always good to have physical copies as well in case something gets corrupted on your computer. But this Excel spreadsheet can be updated every single day or every single hour, and then we can have an average that is calculated based on all of these cells being filled together, right? So reporting takes full advantage of all the Excel properties because it's directly injecting data into the Excel spreadsheet. We can also read data from an Excel spreadsheet if we need to. Very seldomly does that happen, but we offer the capacity to do so. Security, this is what I really wanted to get into. So you can create users and have the ability to log in and log off. So as I mentioned earlier, there's a tiered approach. So 1 through 100 levels, there's 100 levels of security, 1 being the highest privilege and 100 being the lowest privilege level. So by default, you will be level 100. That's what it says right here, base security level. You can actually change the default if you want to. But the highest privilege user being 1 and so forth. So maybe you don't want anyone to have the capacity to do page navigation. You could put security on those buttons. So if I go back into the project and I go over to security, I can create like a level 5. So anyone that is level 5 or higher can now access this button, but the base default user cannot. So, default being 100, right? They can't interact with this rectangle. So that's one way to secure your project, or not to secure the project, but to secure the utilization of the project, right? The internal utilization of the project. I don't want to get too much into it. You have to create users, you have to create passwords. That's done here with the little person icon in the toolbar. I showed you where the security tab was. Again, whenever you click on any object, there is a security tab and you can control the value here. And then these are the commands that you would use to log in. So if you wanted to create custom buttons, like I did, you can create a rectangle that stores the username, a rectangle that stores the password, and then a rectangle that, acts like a login button. So that's typically what you would experience on like a website or any type of logging in interface. You can also log in from the toolbar. I don't recommend doing that. I recommend turning this off because things can go wonky when you leave the toolbar active for every user. So I would actually turn this toolbar off in the runtime. And that is, you are able to do that, I believe, in the settings here. Or maybe, oh, we don't offer that with the web one. So in 3.9, you have that capacity to do that, but I think in this one, you do not have that. So yeah, the toolbar is not active at all, actually. So ignore this slide. This is only for UltimateAccess 3.9. Page properties, static pages. So this is how you get a multiple amount of pages. I don't know if we still offer this here. We do. So multiple monitors, you can have up to, I forget what number we can offer up to, 9. So with ours, you can have up to 10 screens. So it's 9 plus 1, the primary, right? So you can display 10 pages at once. That's how you get like a mainframe, or you see like those TV shows or like movies where they have multiple screens showing different pages at the same time. Like that's something you could expect from this feature. And that's it for the presentation. But before you go, there are some things I want to talk about with the new software. So this is HTML5. It's very easy to deploy. You can do this without a license to test it out. So you're going to set the IP address right here. So that's going to be the IP address of your computer. I would recommend checking the use HTTP box unless you have a certificate that you want to put in here. It's going to be port 80 for your HTTP. And then you choose your starting page and so forth and so forth. And then once you press OK, you're good to go. You just initiate the runtime by running CIMON and then you're going to navigate to this website. So you would be like HTTP, and then if we saw it correctly, it was like this. So this is what you would navigate to if you followed my example right here. So it's HTTP colon / the IP address that you put in the field colon and then the port number. So what I have right here. So some other things. So now the new SCADA software supports 3D objects. So that's right. We support rotating objects in a 3-dimensional manner. So Z, X, and Y. You can attach tags to certain aspects of the 3D object. So maybe it's a building and a part of the building caught on fire. You can attach an alarm to that part of the building and like a fire. You can create like a little fire image that shows up. and like it can be very descriptive 3D model. It also helps out with troubleshooting. It helps out users understand what what the object looks like completely, right? As long as you have like the correct 3D model representation in your project. We offer the capacity for IP cameras. So what does IP camera mean? That is not like your IP65, IP68. No, IP meaning Ethernet. So we support Ethernet-based cameras. So in the previous SCADA software, we supported USB-based cameras, so it was like one or two in your project. But now you can connect to any IP camera. I believe, where is that located? I think it's in, oh yeah, so here we go. IP camera, and then you would just draw it into existence like this, and then you point it at the certain URL. So the file type for the 3D models, I don't know off the top of my head. But it's like OBJ, 3DS. It's all the 3D files that you would expect. I think those are the two off the top of my head. I might be remembering it incorrectly. I can actually pull that up for you. One second. I don't have it memorized, unfortunately. But those two are definitely ones that I think I recall. So OBJ and 3DS. But I can tell you in a second here. So as far as 3D images go, oh, it's 3DB, my fault. So we support 3DB, OBJ, STL, and GLB. Those are the file formats that we support for 3D imaging. So again, those objects are 3DB, so 3 Delta Bravo, OBJ, so Orange Bravo Janitor, STL, Sam, Tango, Larry, and then GLB, Giraffe, Larry, Bravo. Those are probably not the correct terms to use, but you get the point. So 3DB, OBJ, STL, and GLB. So what are some other features that we want to talk about with the new SCADA software? We support the IP camera, right? We support SVG images, which I already went over. So you can import your own SVG images, or you can use the one that are provided in our library. So every single image in this library right here, so you get to that by going to draw library or clicking on library as I did over here. All of these are SVG, every single one of them. And there's over 3,000 images in this library to choose from. So you're more than welcome to look through them at your own leisure. Yeah, so that's pretty much all I wanted to talk about. And then there is page recording as well. So page recording not only allows you to audit your project's utilization, but it also allows you to troubleshoot your project. So say a certain alarm went off, right? You would want to record the page to see what else happens when an alarm goes off. So you can track up to like 60 minutes of what is happening on a certain page when an alarm goes off or is turned on rather. And then last but not least, our SCADA software does offer the capacity for CFR part of 21 part 11. If you don't know what that is, that's the pharmaceutical food industry compliance feature or certification from FDA. So we are FDA compliant for CFR 21 part 11. Some other notable features is we communicate with SQL, right? Like that's a standard feature. I think that should be in every SCADA software. Our IO devices, we have a tremendous amount. So we have over 200 native protocols. So whether you need OPC UA, you need SMTP, you need Ethernet IP, you need S7, you need Modbus, we have all of that covered. There are so many protocols that we have within our SCADA software ready to deploy for you. And then also, I think we have the recipe feature in this software as well. If you don't know what recipe is, that's basically a way of orchestrating like different permutations of calibrating your application. So internal calibration, maybe you already have a permutation that you know works for it. So you'll inject all of those values into the physical IO and it will work efficiently. Or you did a physical calibration externally from the software, and you want to retain those values in the software for later use. So you calibrate your machine, extract those values into the SCADA software. You create a recipe or an ingredient list of that, and then just store it for later use. So that would be the beauty of recipe. It stores permutations of your project for you. Also, we offer redundancy inside this software, and then I think a scheduler as well. So we definitely offer a scheduler. And then also, I already went over the scripting. The scripting remains the same. It's Visual Basic at its very essence. So that's enough about the SCADA software and IPCs. You're more than welcome to stay and ask questions if you have any, but I will be ending the session now as far as presentation-wise goes. So look forward to the recording, the presentation, and the manual that I will be delivering later. So thank you so much for showing up today and listening to me talk.